Hi, everybody. My name is Moshe Zadka. I work for SurveyMonkey as a senior systems engineer. And today I want to talk to you about how to use Jupyter as your incident management tool. My website is cobordism.com, where you can find every way of reaching me known to humankind. I want to start with an acknowledgement of country. I live in Belmont in the San Francisco Bay Area Peninsula, which is the ancestral homeland of the Ramaytush Ohlone people. I want to start with a brief introduction of what Jupyter notebooks are. Jupyter is a language agnostic console. The notebooks themselves are saved as JSON, both the inputs and outputs, but they can be exported to HTML, Markdown, and a bunch of other formats. The thing that does the execution itself is called the kernel. There are different ways to run Jupyter, but they're all called kernels. Basically, it's a language execution engine. Usually what I use, and the most popular thing that people use, is running the IPy kernel, Jupyter kernel in a virtual environment in Python. And that's what we'll use during this presentation. Jupyter, as you might know, came from data science origins. Why was it important for data scientists to have something like Jupyter? Well, they want to share their work with each other, but they want to share it in an executable format so people can double check each other's results. And they want to have something that's easy enough for exploration. And funnily enough, this is exactly the kind of thing that site reliability engineers and DevOps engineers need. We want to be able to share our work with one another, want to be able to double check that our assumptions are correct. And so often we are presented with, as in this example, incidents where we don't know the cause, we need to explore. This is not that different from doing science. There is some truth out there, and what we need is to find it. And at the beginning, we're not sure what it is. To have an incident, we need to have a service that has an incident. I wanted to simplify a service so that I can present the incident from start to finish in the time that we have. So we have a pretty simple imaginary stack. We have some vague service that does something, but it does have an SLA. And our team, as many site reliability teams, is in charge of the SLAs. And the beginning of the story comes when a page comes in that one of the SLAs has been violated. Now, sometimes people present the incident as a detective story. This is not one of those times. I will present the problem and I will tell you the solution before we even dive in, because I'm not trying to teach how to do incident analysis. I'm trying to figure out how to use Jupyter for that. So the symptom is the P90 latency is spiking. I'm sure many of us have been in this situation. Different servers are not homogeneous in this cluster. Each service might be dealing with a different shard that has a very different typical behavior. So figuring out which server is actually misbehaving and spiking our P90 latency is not that trivial. We need to figure it out and apply the fix so that everything can go back to being inside the SLA. As I said, I'm going to tell you the answer to begin with. One of those servers had a core file dumped because of issues dealing with how the server is implemented that result in spam queries, but not all of them taking too long. Maybe they accidentally are scanning that core file and take a while to do that. Some queries don't do that. So it's a pretty complicated story data-wise. Like not all a specific server is misbehaving and not all of the queries on that server are misbehaving. So let's dive in to see how we can figure what's going on. Well, the first thing you do is probably like look at some monitoring system. I use Prometheus because I could run it for free on my own system. And you see the picture, and the picture is kind of hard to figure out which of those lines is like bad, right? They all kind of like, crisscross each other, and they all, like, I'm not really sure what's normal here. The first thing I did was I put that picture directly in my Jupyter notebook. This means that later on, when I want to reference, I can see like what was the initial picture that I had that started me on this investigation. But Prometheus is designed to have the queries be really easy to write through like a teeny box in the web interface and to make pretty graphs or sometimes to use in alerts. it's not really designed as a query language to do data analysis and slicing and dicing. You can try to do that. Your queries will get really, really big. Probably will not fit it in the teeny box, and it will be hard for you to read them and understand what you're doing. It's an awkward language for that use case. It's not designed for that use case. Instead, what I'm going to do is I'm going to write a simple query. You can see that the query here is pretty simple, right? It's just telling me, you know what? Don't try to slice and dice this for me. Just give me all the data. And then I can, just check the data to see that like I actually ran the right query. But this is way too much data, right? Like I have 5 servers, I got 5 minutes worth of data in 10-second steps. So it's 30 data points per server. I have 4 servers. That's already 40 data points. If I'm gonna try and look at 40 numbers, as a human being, the only thing I'll be able to do is like put them on a graph, and I already had that graph. So clearly that's not gonna be useful. But this is very different from what you think of the typical use case for Jupyter already. You think of when data scientists use Jupyter, the notion big data is thrown about, right? And people can argue about the definition of big data, whether 10 gigabytes is big data, or whether you need 1 terabyte to deal with big data. We are at the other extreme. We have 40 data points. These 40 numbers, that easily fits in like 1K of memory. But it's still too much for a human being, but obviously not too much for any reasonably modern computer to slice and dice. So let's write some slicing and dicing code, right? So it's pretty hard to write a query that will do that, right? Figure out the amplitude per server. But it's very easy to write a little bit of code that scans that stuff. And it doesn't matter how slow the code is. Again, this is Python, definitely not the fastest language, but it only needs to query 40 numbers. We don't need to use something like pandas or NumPy. And this is, again, very typical, even if you have a slightly bigger systems, right? Like, if you have 1,000 computers, right, 1,000 servers, each rating, like a few data points, right? You might be dealing with 100,000 data points, which sounds like a lot to a human mind, but nothing for even the slowest language that we can run it in. So this kind of stuff, instead of trying to shove it into Prometheus, make sure that Prometheus can do it, we have a full-scale language, and we figured out which server has the biggest amplitude. Since we already suspected that the problem is that like some queries are taking okay and some queries are taking a long time, the amplitude is how we find the suspect server. Again, like in real life, we might have had some more slicing and dicing, but obviously we only have so much time to do that. So we found the object 4, right? So great, we found the suspect server. Now we need to figure out the problem. So let's figure out what's going on wrong with object 4. So for actually connecting to AWS, we're going to use Boto3. That's a library that connects to AWS. We're not going to put the username and password in the notebook. This is really important. In this case, I'm sharing the notebook with a lot of you folks, and I don't know most of you, but even in real life, if you do that, that notebook is going to be shared, right? The whole reason we have a notebook is to share it. We're going to put it in a ticket, possibly inside Git. You don't want usernames and passwords sticking into these things. So you want to keep your username, password, all your connection parameters in a separate file. In this case, I put it in a JSON. By default, AWS will put it in a CSV, but I need to reformat it for all kinds of reasons. But you're reading the parameters here, and then you use the Boto client to connect to EC2. Now that we're connecting to EC2, out where object 4 resides. Again, in this case, you could probably start improvising with the AWS console or maybe the AWS CLI and start figuring out where the object 4 tag is. But imagine that in situations that are more complicated, this is going to get really messy really fast. For example, what if there's a few objects tagged and they're not actually tagged with that, they're tagged with something that matches a regular expression, and you actually need to cross-validate it with a different tag, or maybe the operating system it's running. You don't, even if you could shove those queries into this teeny thing in AWS console, it's going to be a pain. You could, of course, start with like a 5-line grep pipeline, also not fun. Here, we have a real programming language that gives us regular expressions, that gives us Boolean expressions, that gives us any kind of logic we want, any kind of for loop. We can keep things in lists and dictionaries and whatever we want. And because of that, writing that code was pretty easy. And we found a culprit. That's this ECS2 machine. This is great. Now we not only know the logical thing that went wrong, we know that object 4, but we know the physical machine where the problem actually happens is this. So this is great. We found the instance, and it's some big hexadecimal number that we don't have to remember because we can get it from the previous thing. And now it's time to actually log in and fix the issue. So let's fix the issue. We'll use the paramicro SSH client. We can just use the missing host key to make sure that like we don't have to set the host keys correctly. And we log into the private IP address. We got the warning we expected that like, I don't know what this SSH public key is, but that's fine. We're using the private IP address. We're inside the VPN. That's probably not a big problem. And now we've connected to the thing. So we can start exploring just as you would with an SSH command line, but now we do it all from the same single pane of glass, our Jupyter notebook. So let's first confirm the problem with 1ls. Again, like in this case, I already suspected that the problem was core file. Maybe this is a standard runbook. We know that some of our servers dump core files and that causes a problem. Sure, we're gonna fix it probably in the next update. For now, we're just gonna delete the core and be done with that. So let's check. Okay, we have a core file. Clearly, we want to delete that. So let's delete it. And then like 1ls again, just to be sure that my output is clear. I did this print so that like we see that I actually did 1ls. And there's no outputs, right? So in this specific directory, there are no more files, including the core. The core is gone. So the problem is actually fixed. This is, by the way, very typical. You want to make sure that as you do the notebook, your output is kind of easy to understand and easy to confirm that you've done the right thing, because that notebook is going to be valuable later on. So we fixed the problem. Great. An incident does not end when the problem is fixed. You know, sure, in real life, you also want to go back to Prometheus or make sure that the page is gone, but presumably you've already done that and you've gone back to sleep, right? Because it's always incidents happen at 3 a.m. So you've gone back to sleep, but the incident is not done, right? It's the problem is done, but there's a important part of the incident, which is post-incident. We need to do the post-incident report. Someone eventually wants to fix the core things, which means we want to make sure that we understand how often it happens and all of that. So the next morning, or you know, whatever time your normal work next, you duplicate the notebook because you want to keep the old notebook pristine. This is exactly the log that happened. You want to keep it for posterity, but then you duplicate the notebook. And now one of the nicest features of Jupyter, you can add notes in Markdown, which means you can just add another cell that is not an executable cell, where you explain why you did that, right? Like, I looked in like this page in our runbook, and that's why I ran ls. This was very unclear because our runbook has this stuff in it, and then you put a quote from the runbook, exactly what it said, which shows why it was unclear. Again, you can put like, you know, this happened, this is the second time this happened. And in this case, my story was pretty clean because I knew what the problem was and I wanted to take us down the garden path. But in real life, of course, you'll find 5 things that didn't work. You want to tag them with like, here's the thing that didn't work. The reason I suspected it was blah, 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 right? So you have a place for all these notes in the Markdown together with everything you've done. Now you have a really good document to actually look at the post incident. And now the nicest thing is that you can export it to HTML. So doing the incident retrospective, this might be shared, like the computer that's sharing everything might be the computer of someone that's not necessarily an engineer, maybe some facilitator. they probably are not going to have Jupyter, but you export it to HTML and you attach the HTML to the incident ticket, that person can double click on that, open it in their browser, and show, here's what happened during the incident. You have the entire log, plus all the notes you helpfully added during markup. Maybe you even added, timing, or say, at that point, I reached out to this person to help me, right? And then, it's a natural point for the facilitator to say, and what happens then, right, to that person. So you have all these notes, but you also attach the notebook to the incident ticket. Attaching the notebook to the incident ticket means that all the code you run, all the ad hoc queries you have, are saved for posterity. If they're going to be useful later, maybe you can put it in a library that you load up as soon as you load up your Jupyter for the next incident. If maybe this is going to be useful in your actual product for some automated remediation. Whatever you want, you have that notebook, right? Even if the only time you'll use it again is, oh, wow, this is very similar to the incident we had last week. Let's dig up that ticket, open that notebook, import it into my current Jupyter, and see if any of these things are going to be useful. That's a great use for that. So this is a really, really important thing. An incident is not done when the problem goes away. An incident is only done, when the post-incident is done and all the discussion has been done and you decide what's the action items that result from that, and Jupyter facilitates that part as well. So here are a few final thoughts. Incident resolution, that's an exploratory process. You do not know at the beginning what is going to be the end of the story. You're going to go a lot of dead ends. It's really important to log those dead ends, right? Those are going to be useful later on. For example, if you ever are training another person, this is really good training. Like, don't do those things, they never work. Do this other thing. So this exploration is an important part of the incident resolution. We should not hide from it. We should lean into that and say, this is an exploration thing. I also want to note that a lot of people think when I talk about this is some useful auditing. This is not an auditing tool. Jupyter by design allows you to edit cells, allows you to execute cells over and over again, not in order. This is a great feature while you're exploring the incident. If you want an auditing tool, get an auditing tool, right? Your auditing tool should do auditing, right? Whatever, for example, if you use AWS CloudTrails or whatever, then you know that it's doing AWS CloudTrails, right? If you use some auditing thing that like audits SSH sessions, and it audits SSH sessions. You should not try to corral Jupyter to being your auditing tool. It's not going to be good for that. You're going to be suffering, and Jupyter is not really a good utility for that. It is a great tool to share knowledge with your team. Almost by definition, for incident response, we need a team, right? This is why every single on-call tool has a rotation. I'm not going to be on a rotation every day on my life, which means tomorrow or next week, probably someone else is going to be on call. This is a way for me to share knowledge from my incident to that person. And you want to be prepared for retrospective. Even as you're managing the incident, you should keep in mind, the only way to make sure that you don't wake up again at 3 a.m. is to have a retrospective and to figure out how things went wrong and what we can do to prevent it in the future. As you're managing the incident, being prepared for a retrospective is really important. And this is why you want to keep output in your Jupyter notebook as clean as possible for the Jupyter. This is why, a little bit of like star printing to kind of make sure that the output is actually usable, not just to you in the here and now, but to future you as you're presenting the incident is really important. So with these thoughts, I hope I left you with understanding of how to take advantage of Jupyter and make your incident management a little bit better. If you have any questions, I did put all the ways to get in touch with me on my first slide. It's at cobordism.com. You can have my Twitter, my email address, my LinkedIn. Please reach out whatever way you find is most useful. I love talking about best practices of incident response management. Thank you, everybody.